In this presentation, you will learn that light is just one example of a category of wave energies called electromagnetic radiation. Electromagnetic waves include radio, microwaves, infrared radiation, UV light, X-rays, and gamma rays. All these waves are produced by the oscillation or vibration of a charged particle and travel at the cosmic speed limit of 3 × 10⁸ meters per second in a vacuum. When the source of the electromagnetic wave vibrates slowly, radio waves are produced. The most dangerous waves like X-rays and gamma rays are produced when the charge that produces the wave vibrates very rapidly. Here is the entire electromagnetic spectrum. You can see that the most dangerous waves are on the right and have a high frequency and a small wavelength. Gamma rays and X-rays have the highest energy and easily penetrate into the human body. Radio waves and microwaves are the least penetrating and have the longest wavelength. Some radio waves have a wavelength as tall as a city skyscraper. The only wave that is visible to the human eye is light. In the next video, you will see that all living things emit an electromagnetic radiation called infrared. Infrared waves have a wavelength as small as the tip of a pin.
The world sure looks a lot different in infrared light. Remember that what you're actually seeing is temperature. So something that's warm is going to look bright in the infrared. And something that's cold looks dark. Ice cream. Blow dryer. And infrared radiation is actually a measurement of temperature. Places on my face that are cold, like my nose, appear dark in an infrared camera because they're giving off less infrared radiation. And places that are warm, like my mouth, or the hair next to my head, are brighter because they're warmer. You can even see my breath in my nose if you look carefully. And this is an ice cube.
Electromagnetic radiation are waves of energy generated by the acceleration or oscillation of charges. Why can't neutrons make this kind of wave? Neutrons cannot make this kind of wave because they have no charge. Electromagnetic waves can be produced by the oscillation of charges. They travel at the speed of light in a vacuum, 3 × 10⁸ meters per second. The charged particle shakes off a wave of energy with every oscillation, much like a dog shakes off water after a bath. The red dot in this animation represents an oscillating charge. An oscillating charge emits transverse waves. The wave is transverse because the direction that the wave travels is perpendicular to the vibration that produces it. The following chart is found on your reference table. It is a list of the full spectrum of electromagnetic radiations in order of increasing wavelength. You need to know that all the waves listed here are transverse, do not require a medium, and travel at the speed of light through a vacuum. To give you an idea of how fast the speed of light is, imagine that you are seated at the highest point in a baseball stadium. When the batter hits the ball, the sound is changed to a radio wave and is sent to TV sets all around the country. Radio waves are so much faster than sound that the person watching the game on television hears the crack of the bat before the person at the stadium. Your reference table can be used to answer a lot of questions about electromagnetic waves. If you ask which wave has the smallest wavelength, you can see that the chart lists the wavelengths from the smallest, gamma rays, to the greatest wavelength, going up to 10⁴ meters, radio waves. It's just a matter of reading it right off the chart. Those low wavelength waves are so dangerous because they have a very high energy and can penetrate deep inside the human body. Excessive exposure to the energy of these waves can damage the DNA inside our cells and cause cancer. This is why we limit our exposure to X-rays and wear sunscreen in the summer to block the penetrating UV light found in sunlight. X-rays were discovered in 1895, but the long-term dangers of this radiation wasn't understood for quite some time. Up until the 1950s, many upscale shoe stores had periscopes. Periscopes let you view an X-ray of your foot in a shoe. In 1957, the state of Pennsylvania became the first state to ban the use of the periscope By 1960, pressure from insurance companies led to the demise of the shoe-fitting petoscope in the U.S. If you're asked to find the electromagnetic wave with the smallest frequency, we look at the bottom of the chart. We can see that the gamma rays have the highest frequency and radio waves have the lowest frequency. Notice that this chart also gives you the frequency range for the 6 colors that make up white light. Let's suppose you wanted to use the chart to find the color with the largest wavelength. Since the large wavelength waves are found on the right and red is the color that is furthest to the right, we know that red is the color with the largest wavelength. It's the color with the largest wavelength and lowest frequency. If red has the largest wavelength, then it stands to reason that the color violet has the smallest wavelength. Using the same logic, we can conclude that green has a greater wavelength than blue. Which color of light has a frequency of 6 times 10 to the 14th hertz? If you are given a frequency of light, you could use the diagram to find the color. A frequency of 6 times 10 to the 14th hertz fits within the range of the color green. Be careful when you read the chart because the left side of the frequency range for each color is higher than the right. What is the color of light whose wavelength is 6 times 10 to the negative 7th meters? In order to find the color of this light, we need to know its frequency. If we have a wavelength and are asked for the color, we need to use the velocity equation to find the frequency. Using the speed of light in a vacuum as 3 times 10 to the 8th meters per second, we find that the frequency is 5 times 10 to the 14th hertz. Since the frequency of the light is 5 times 10 to the 14th hertz, the color fits within the range of orange. This is the end of my presentation on electromagnetic radiation. We learned that electromagnetic radiation can be created by the oscillation of charges. When a charge oscillates at a certain frequency, it creates a transverse wave called visible light. If the same charge oscillates with a higher frequency light, UV light, X-rays, and gamma rays are created. If that same charge oscillates with a smaller frequency, radio waves, microwaves, and infrared light are produced.